Okay, so we're going to start with these two and just take a look at 9 and 11 here to help you. So we have a square root in our problem. Undo a square root, we square. 6 squared is 36. And then on this side, the square root and the squared cancel, and I have 3n. Divide by 3 on both sides. 12 equals n. Yeah, it's not too bad. It's not too bad. Okay, now number 12, though, is the opposite. So we want to get n squared by itself, and then we're going to square root. So minus 9 first. Then divide. Okay, then square root both sides. On this side, the squared and square root cancel, and you just have n. Okay, and what's the thing? Yes, but what do we have to remember when we square root? Plus and minus. Plus and minus 2. So again, whenever we square root both sides, we have to remember the plus or minus. That particular thing is not going away. If you forget it, it's like -1. Does that make sense? Or -0.5, depending on how many points the problem would be worth. Um, okay. So can you guys now find the quiz review, please? The quiz review is not technically due yet. Also tonight's homework, which is why I didn't stamp, by the way. But a bunch of you wanted stamps anyway, which is amazing and wonderful, fabulous. Very excited about that. Okay. What question? Take a look at this. What questions do you have for me from the quiz review? Is there anything I can help you with on here? Please take a look through it if you haven't done it yet. Take your time. I'm more than happy to help. 6 and 7, yes, sir. Okay. Great. Do you guys just want me to do all the literal equations? Okay, that's fine. That's fine. We have time. It's fine. Okay, so the first thing I'm going to do is notice which letter it wants me to solve for. So I'm just going to put a little baby highlight on them. So this one it wants me to solve for. Are they all A? Oh, that's kind of good. Okay, so I like the little bit of a visual piece to help me see what I want to get by itself. So I know I'm done when A is by itself in this problem. So the first thing I'm going to do is get rid of the last thing that happened, and the last thing that happened was minus B. So I'm going to undo that by adding B. Yes, honey. Nope. But that's tomorrow's, I believe. So you're ahead. Okay, now this is multiplication. So I'm going to divide by C. And the reason I'm dividing by C is because that's the thing I want to get rid of. So G plus B over C equals A. Okay. Now, Evan, was it that you that wanted 6? Okay, so for 6, the trick on this problem, it's not a trick, it's a piece of information that you need, is that when you divide, you can divide by multiple letters at the same time. So this is all multiplication, so I want to divide, I can divide by C and B at the same time. And it crosses both of those out, and then I get G over CB equals A. Okay, so let me say that again. It's okay to divide by multiple letters at the same time. It makes it easier for you, because otherwise you end up with like a fraction and a fraction, and it looks really weird. Okay, now number 7 though is quite a bit harder in my opinion. I know. Well, who knows? It could be anything with these. So you guys all know that this is division, right? So I want to, or I mean, multiplication. So you want to undo it with division. And I want to get rid of the C. So I have A equals D over R over C, and not, that's not, that's weird. It's not. Okay. And if you looked at the, it's not. And if you look at the answers in the back, I don't think that it's the answer. Okay, so let's look at the answer real quick. Definitely not. Okay. Okay, so let me show you how to fix it and get that. There's a couple of ways. First, you can, well, no, we're just going to do it the way I want to. Okay, so what I will do is put the C over 1 and then keep, change, flip. So this is dividing fractions, which is keep, change, flip. So that means I have keep the D over R, change to times, flip C over 1. That's not right. I didn't flip it. This is why I live in the land of erasable pen. Yay. Okay, and now I have D over CR. Keep, change, flip. Okay, now 8. I'm going to do 8 in 2 steps. So I want A by itself. This is subtracting, so I'm going to go plus B, and then this is also subtracting, so now I'm going to go plus C, plus C. That's it. And the order does not matter. I like to put them in alphabetical order because I'm a nerd, but you don't have to. Any other questions from the quiz review other than the literals? And these are definitely not anybody's favorite. So if they're not your favorite, you have that in common with everyone else in the room. Okay, maybe there's one person that left. Is it me? It's just me, isn't it? Okay, anything else from the quiz review you guys want to talk about? Yes, 9? Okay, what is 9? Solved by graphing? Okay. Okay, so we graph them separately. Ruler, find where they cross. Okay, so start with -4 on B. And then the slope is 5/3. So I'm going to go up 5 over 3. Right, now the other line, B is positive 4, so I'm going to go up 4. And the slope is negative 1, so I'm going to go down 1 over 1. And look, it hits that dot perfectly. Okay, now what type of answer do I put? This is not done. I did graph them, but I didn't solve it. What type of answer do I want? Coordinate, right? Now the problem is done because I put the coordinate where they cross. What? Oh, that's okay. Does it make sense though? Yeah. Okay. All right, you guys. Can you please set this off to the side? I'll take individual questions on it when I'm done teaching. But for now, I need you guys to set this up, please. So I'm gonna come up here to the front. And I wrote this stuff over here to help us out over the next couple of weeks. And so this is how you decide which method you want to use. So if they're both y equals, and it doesn't have to be y, but if they're both equal to the same letter, you want to do equal values method. Are these both equal to the same letter? No, the top one's y equals, but the bottom one's in standard form. Okay, if one of them is equal to y, then you want to do substitution method. You guys see that that's how this is set up. So one of the equations is y equals and one of them is not. Okay, so you want to do substitution method. There are going to be people in the class who just love equal values only. Their heart is only for equal values and they don't like the other ones. My goal today is to show you why equal values is not always the best. Okay, so remember, how do we do substitution? So first thing I'm going to do is write this. Just in case you're flipping back through your notebook and you're looking for an example of substitution. And one of the equations is equal to y and one is not. Okay, so this is what you do. You take the part of the equation that's equal to y, and I like to put it in a box. So whatever's after the y equals, I put that in a box. And then I make an arrow to what that equals in the other equation. So y equals this stuff, so I make my arrow to y. What that means is I'm going to take this y out and I'm going to replace it, substitute it with these things. So I start with 5 And then the y becomes this in parentheses. So I have 5y, y is now that, plus 3x equals negative 13. So 5, y is now this, plus 3x equals negative 13. And why did I do that? Because now I have an equation with just x's in it. I have one equation, one unknown, instead of two equations, two unknowns. Okay, now distribute the 5, negative 5x minus 35 plus 3x equals negative 13. Combine like terms. That's 22, right? Okay. So we have our x. It came out nicely. Don't be freaked out if they don't always come out nicely. It doesn't always happen. And now I need to plug it back in to get the y. And I like to plug it into the box for these because it's the easiest. So y equals negative x minus 7. So this makes positive 11 minus 7, 4. Beautiful. Okay, so I have negative 11, 4. Okay, what does this mean? What does my answer mean in words? And think about the problem I just did on the quiz review number 9. Yes, both of the lines intersect at negative 11, 4. So if I were to graph both of them, they would cross at negative 11, 4. And I'm really glad I didn't graph them because I don't want to go out to negative 11 really, really bad. So that's one of the reasons substitution method is nice. Okay, does everybody understand what that answer is? So if I were to graph the lines, which I didn't because I'm lazy, they would cross at negative 11, 4. Any questions about this substitution business? Okay. Here is number 56. It's going to feel familiar. Okay. Yeah, on purpose. Okay, now we're gonna do number 56. And my goal for number 56 is for you to take number 56 and like number 55. Number 56, we're gonna force this problem to be equal values method because there are people in the world who just like, can I do equal values method for everything? I think you could. I'm hoping after this problem, you'll rethink that idea. Okay, so 56, equal values method. The first thing I notice is that the top equation's already y equals, so I don't need to work on it. Noah, can you please stop that? 5y plus 3x equals negative 13. Okay, so we're going to practice what we learned at the beginning of the chapter and get y by itself. So I'm going to undo the x first. Divide by 5. Now this moment should be enough to scare you into not doing equal values method, but maybe not. We'll see. Okay, so now we have two equations for y equals. We can equal them to each other. And really, it just turned the problem into a fraction buster. What is the least common denominator? 5. Great. So times 5, times 5, times 5, 5. Okay, if I did this right, they should come out evenly now. Okay, so to answer your question, could you do equal values method for everything? Yeah. No. But if if you hit a fraction, maybe it's just not the best. Should you do equal values method for everything? No, you can live your life just, staking your flag right into equal values method. That's all I'm gonna do, but I don't know. I just wouldn't personally. I would follow my little chart over there and figure out which one is easiest. But we've only really worked on equal values and substitution so far. We have to do more elimination method. Okay, setup number 50. I did not finish this one, by the way, because it comes out to the same answer. But because my whole point there was just to prove a point. But go ahead and set up number 58. 57 is a heinous word problem.
So,
We're gonna do a word problem after this,
okay, that makes sense.
but that one is it's horrible. Oh, it's good too. I do have it. I'll show you after. Okay, so number 58 is really more of a vocab problem than a math problem. Uh, it's asking, is 1/6 a solution to the system? This is called a system of equations. And this is saying, is this the point where those two lines cross each other? Okay, we don't want to graph them or anything. We're too lazy, right? So you could reword this question, or is x equal to 1 and y equal to 6? This is how you could translate that question into making this a much simpler problem. So is 1/6 a solution to the system is also asking, is x1 and y6? Okay, so let's put those in and see. So 4 times 1 plus 3 times 6 equals 22. Is that a true statement? Yes. Okay, now we have to see if it works in the other one also. 1 minus 2 times 6 equals 0. Right, we have one more problem, and it's a heinous word problem. It's not heinous. It's just something we're practicing right now because the word problems are hard. We're just practicing. Okay, here we go. Oh, I'll show you the joke at the same time. Okay, so here's our agenda. We're working on equal values and substitution method. We're also working on word problems, but yeah, it's hard. The homework is to finish the quiz 1 review worksheet, and that is my joke. It is a parallelogram. Yeah. You see why we're skipping it. Parallelogram. Okay, 59. You've decided to give your best friend, a bag of red and green marbles for his birthday. Oh man, your friend is going to be excited. Your friend likes green marbles better than red ones, so the bag has twice as many green marbles as red. Okay, we're gonna start with that. So the bag has twice as many green marbles as red. Which one do we know nothing about? Red. We know nothing about red. We know something about green that has twice as many red, but we don't know anything about red. So we're gonna go, okay, x equals red. And it says it has twice as many green ones as red. Twice as many green ones as red. Okay. Right. Forgot what the problem said after that. Oh, I didn't even read it. Okay. The label on the bag says it contains a total of 84 marbles. What operation is total? I didn't hear it. What operation is total? Add, right? When you get the total of something, you add it. So it says contains a total of 84 marbles. So that means that the red marbles plus the green marbles is a total of 84. Did you just do that in your head? So that means that there's 28 red and 56 green.
56 for you guys.